You may have noticed in the previous lessons, all the metals that we pretty much used existed either in the first or the second group. We kind of omitted those ones that were in the center. The reason why we did it, they need special rules. The reason why is because they do not have representative charges. You may have noticed when you were marking the representative charges on your periodic table, we skipped that entire interior section. The reason for that, they don't have them. Using my previous knowledge from prior lessons, if I were going to attempt to name this compound, this first one I would probably name iron chloride. Right? So as far as I know so far, that's correct. And believe it or not, that is a formula of a compound made of iron and chlorine. However, there is another chemical formula of compounds that are made up of iron and chlorine. It's FeCl2. So using your knowledge as far as what you know, you would also call this iron chloride. Well, how can that be? I mean, obviously these things are different. They have different numbers of chlorine atoms attached to them. How can we distinguish between these two compounds that have different properties? Well, there's a system that is used for this, and I'll teach you here on the next slide. Transition metals are going to be those elements found in groups 3 through 12, and also any metals that are found under the stair step. So you drew that stair step line there, starting under boron and going over one down, one all the way down the periodic table. And so every metal that is underneath the stairs, with the exception of aluminum, is a transition metal. So even though some of them are in a representative group, the representative charges do not apply to those metals. The thing you need to be aware of is that a charge must be specified for these cations, once again because they have more than one possible charge. How do you indicate their charge? Well, a Roman numeral is used to indicate the charge in the metallic cation, and they're just 1, 2, 3, and 4. I do need to make a special note. There are 3 transition metals that do have a representative charge, and you need to probably mark these down on your periodic table at this time. You'll notice zinc, number 30, cadmium, which is number 48, and silver, number 47. They have representative charges, so they are always these following numbers. So for zinc, it's always 2 plus, cadmium is always 2 plus, and silver is always 1 plus. So knowing our newfound knowledge that there are different forms of these transition metals, I'm going to demonstrate how you would name these two compounds that are composed of iron and chlorine. I'm kind of going to do the opposite of what we did on the last video, so instead of crisscrossing, I'm going to kind of unzip these formulas so I can determine what the charge in the metallic cation is. So what I'm going to do, I'm going to start with the formula. I'm going to put the cation up here, the anion here. This understood 1 goes there. This number 3 goes up here, and this is 3 positive because it's the cation. I look and see, okay, chlorine is 1 minus. It should be it, so we're good there. So you would name this compound iron, and then parentheses, Roman numeral 3, chloride. Okay, notice the 3 does not mean there are 3 irons. The 3 applies to the charge of iron. This 3 tells me that iron's charge is plus 3. Looking at this other example, I do the exact same thing. I put iron up here, chlorine up here. This comes up, 1 minus. This goes over here, 2 plus because it's the cation. This one would be iron 2 chloride. Once again, it does not mean there are 2 irons. It simply means the charge of iron is 2 plus. All right, let's try this one. We have copper and chlorine. So just as before, I'm going to write the cation, the anion. This understood 1 goes here. This understood 1 goes there. Notice chlorine, that checks out. So this is copper 1 chloride, copper 1 chloride. This same system works, regardless if you have a monatomic ion or a polyatomic. You do it the same method. Manganese is Mn. OH is the polyatomic ion, that's hydroxide. Okay, notice the 1 goes up here, the 2 comes up here, and so you look at hydroxide, is its charge -1? Yep, so we're good. This is manganese 2 hydroxide. So it's telling me the charge of manganese is 2+ in this instance. Here's another one. We have lead as the cation. The polyatomic anion is phosphate. This 3 comes up here. Notice the 2 comes up here, 2+. Notice the 4 does not move. The 4 is part of phosphate. And so this is lead 2 phosphate. And it's just telling you the charge of lead is 2+. Here's an example where we run into a little stumbling block. Okay, I'm going to write lead up here and oxygen over here. Okay, this understood 1 goes there, this 2 comes up here. All right, but I look at these elements. Okay, lead, I don't know the charge of it, it varies. But oxygen I know should be 2 negative. But in this case, it's 1 negative. Well, that can't be. So how do I get that 1 negative to be what it should be? Well, you've got to double it. Well, if you double one, you've got to double the other. So this compound is actually lead 4 oxide. Okay, once again, it doesn't tell me that there are 4 leads. It doesn't even mean, there are 4 oxygens. This 4 only refers to the fact that lead's charge is 4+. Okay, here's one for you to try out. It's a compound containing nickel and bromine. Go ahead and pause the video, see if you guys can unzip this and determine what the name of this compound should be. Alright, looking at this, you notice the metallic cation is nickel, the anion is bromine, this understood 1 goes there, the 2 comes up here. You look at bromine, bromine's in group 17, it should be 1-, so that's good. Nickel, in this case, is 2+, so this is nickel 2 bromide. Nickel 2 bromide. Okay, I'll let you guys try a couple out. Go ahead and attempt to write the name of this compound. Go ahead and pause the video, and I'll come back here in a minute and I'll show you the answer. Alright, this compound, you start out, okay, iron goes up here, oxygen goes over here, this 2 goes up there, this 3 goes over here, 3+. Notice oxygen is 2-, so we're awesome there. So this must be iron 3 oxide, telling me the charge of iron is 3+. The naming portion is actually the tricky part of these problems. If you've got the name, the formula is actually very easy to write because you simply just follow the directions. Cobalt is CO. Notice that 3+, it refers to the fact that, or the Roman numeral 3 refers to the fact that cobalt's charge is 3+. Bromide just comes from bromine. It's 1-. So I write the formula COBr. This 3 comes down here. The 1 goes over here. It is COBr3. That is cobalt 3 bromide. Here's another one. Tin symbol is SN, comes from its ancient name stannum. Notice the Roman numeral 4, that means it's 4+. Chloride is Cl with a 1-. It's representative, so I write SnCl. The 4 comes down here, the 1 goes over here. SnCl4. That is tin 4 chloride. All right, here's another one with another twist to it. Iron is 2 plus. Sulfur, or sulfide, is 2 minus. So I write FeS. This 2 comes down here. This 2 comes down here. Notice they're equal and opposite. Iron 2 sulfide is FeS. You must reduce. 2 to 2 becomes 1 to 1. Okay, time for you to practice a couple. Nickel 2 acetate. Go ahead and pause the video. See if you can do this. I'll be back in a minute. All right, nickel. Nickel is Ni. Nickel, the 2 plus, or the 2 means it's 2 plus. Acetate, as you recall, that polyatomic ion C2H3O2. It has a 1 negative charge. So I go ahead and write this NiC2H3O2. Just as before, I take this 2 down here, but I can't put just the 2 there because then it looks like 22. You got to put parentheses in the 2 outside. This understood 1 applies to the nickel. So the formula is Ni parentheses C2H3O2 parentheses 2. That is nickel 2 acetate. Here's another one for you to try. Iron 3 phosphate. Go ahead and pause the video. Okay, iron. Iron is Fe. In this case, its charge is 3 plus due to the Roman numeral 3. Phosphate is PO4. Its charge is 3 minus. FePO4. This 3 comes down here. This 3 comes over here. Notice they are equal and opposite. They cancel. FePO4 is the formula for iron 3 phosphate. Last one. Lead 2 nitrite. Go ahead and pause the video, see what you come up with. Okay, lead is Pb 2 plus. Nitrite, notice it's nitrite. I snuck one in there on you with an ITE. It's NO2, but it has a 1 minus charge. So I write the formula PbNO2. This 2 comes down here. This 1 goes over here. So it is Pb parentheses NO2 close parentheses 2. That is lead 2 nitrite.